Okay, lesson 19. First question for you. Which elements are the most stable? It is the noble gases. They are known to be the most stable. What does it mean to be the most stable? They are the least reactive. Excellent. All right, next question. Which elements are the most reactive metals? It is the bottom left right here, but in general, whoopsie, oh well, the alkali metals are the most reactive metals. And if you're really paying attention, you know the next question. Which elements are the most reactive nonmetals? It is the halogens. Oops, I already used orange. Oopsie, I didn't mean to write that either. Okay, things are deteriorating quickly. Most reactive, that's what I wanted. All right, so we are going to pick one of each. We'll pick fluorine, neon, and sodium and start to make some comparisons. We will pick fluorine, neon, and sodium. Fluorine, neon, and sodium. All right, so the question is, make note of, it's not a question, make note of how their electron arrangements compare. So when we look at the comparison between fluorine, neon, and sodium, what we notice is fluorine is missing an electron right there, but neon has that electron. And then sodium has one more shell with one electron in it. So from fluorine to neon to sodium, we go from 7 valence electrons to 8 valence electrons to 1 valence electron. And we know that fluorine is very reactive and sodium is very reactive, but neon is not. So the chemists of long, long ago have said, I wonder why this is. How can we explain why fluorine is so reactive and sodium is so reactive, but neon is not? So we look to neon and say, what's the difference? And what we see is from fluorine to neon, there is a gain of 1 electron. In terms of the electrons, fluorine never becomes neon. If we look at sodium and say, you look at neon and what do you see? From sodium to neon, there's 1 less electron. And that is not how I wrote it in my notes. That's okay. So if we, if sodium wants to get rid of its electron, we'll take this, we're going to take this. If sodium is going to get rid of its electron and send it over here to fluorine, now sodium loses 1 electron, fluorine gains 1 electron, and now look at all of their electron shell models, they are all identical. Fluorine now has an electron arrangement just like neon. Sodium has an electron arrangement just like neon. Sodium lost an entire shell. So fluorine had 7 valence electrons. It has gained 1. I'll go ahead and draw it the same color as it came from sodium. Sodium had this shell here, but it's gone. And now what's left is the shell below it. They now all have the same electron arrangement, and that's the key of reactivity. Oh, that rhymed. That's the key of reactivity. Elements that are a little short of electrons compared to a noble gas will gain electrons. Elements that have got just a few extra electrons compared to a noble gas will lose them. We still have fluorine, we still have sodium, but now sodium becomes a positively charged ion. Ion is anything that has a net charge. Sodium has lost an electron. Sodium originally had 11 protons and 11 electrons. (11 protons and 11 electrons. Now, it has 11 protons and only 10 electrons. So when you combine that right there, you have a net positive. So you lose an electron, you become positive. Fluorine becomes a negative ion. Oh man, why didn't someone tell me? All of that sodium's, oh no, I'm fine. Never mind. I'm totally good. Never mind. Fluorine originally has 9 protons and 9 electrons, but now it still has 9 protons, otherwise it's not fluorine, but it's gained an electron, so it has 10 electrons. That means that fluorine now has a negative charge because it's got an extra negative particle. All right, one more thing here, and then a little bonus. The positive ion is called a cation. The negative ion is called an anion. So once we have a negatively charged ion and a positively charged ion, they will attract to one another because opposites attract. One day, 2 sodium atoms were walking along, and one of them stopped suddenly and said, wait a minute, don't move. Oh man, I lost an electron. And the other sodium atom said, are you sure? And the first sodium atom said, yes, I'm positive.